All right, guys, so we're going to look at comparing decimals. This is something that you should have learned last year as a fourth grader. Uh, the only major difference between fourth and fifth grade is now that you're going to be dealing with some numbers going into the thousands. So here on this page, you're looking at three numbers. They're all decimal numbers. One of the things that I would want my students to think about looking at these three numbers would be they're all smaller than a whole. They're all parts or pieces. So these are really small numbers. But you could have a problem where you're having to compare really small numbers. And so the first step here, I'm going to read all three. You have 39 hundredths, you have 345 thousandths, and then you have 35 hundredths. When you are comparing decimals, the easiest way to do it, I would say the less stressful way to try to compare, just make it as easiest on you, is just to go and line up the decimals and make everything nice and neat. That's usually the first step. So I'm going to start with rewriting this as 39 hundredths. I'm going to put the decimals where they're lining up, 345 thousandths, and then 35 hundredths. Now, looking at this, if you wanted to compare them, a lot of times kids would look at this and they see just numbers and they see digits and they go, okay, well, this one here must be the biggest one because it has three digits. When in reality, what you've got to understand about decimals is, especially if you're going into the thousandths, if you have a number like the first one or the last one that doesn't have a digit in the thousandths place, you have to fill it in with a zero. And so I always tell my students to, line up the decimals. That's kind of step one. And then step two would be make all your numbers look the same by adding zeros. So in this case, if I add zeros in, I would add them to the top one and the bottom one, and now it's much easier to compare. In fact, at this point, I would probably tell my students just say, forget the decimal, let's just look at them as 390, 345, and then 350. And so now when I'm looking at this, it's really easy to see, all right, yeah, that middle one was not the biggest one, it actually was the smallest one. 390 thousandths is the same as 39 hundredths where it began, but this most definitely would be the biggest one out of the three. So lining up decimals, adding zeros to make all your numbers look the same, are really the main two steps that you would want to go through when solving these problems. So the second page here is really the same concept, only now you're dealing with a number or some numbers that have some whole numbers. And so I'm going to read these. So these have some whole numbers with them. This is 12 and 85 hundredths, 12 and 345 thousandths, and 12 and 9 tenths. So these are already lined up nice and neat. So step one's kind of already taken care of. Step two is definitely not taken care of because they don't look the same. And again, I wouldn't want any of my students to overdo things. Don't overthink this. We don't need to go and add like 10 zeros at the end of a number. We just need to make it go to the thousands. And so you'll notice the top number here needs a zero. The bottom number actually needs two zeros. And then now when I look at this, it's kind of like, okay, well, visually, I've got a lot of digits here, so I could go place value at a time, or I could just notice, well, you know what, they're all 12 and something. And so really when I'm starting to compare these, I'm probably going to be looking in the tenths, hundredths, or thousandths place. So what I might tell my students is at this point, I'm not even going to think about the 12, but I am going to be looking at the decimal place value. So I'm going to start with the tenths place, and right away I notice that this 9 is bigger than the 3 or the 8 that's above it. And so if I was going for biggest number here available on the page, 12 and 900 thousandths is going to be the biggest one. It started as 12 and 9 tenths, so visually it looked small. But now when we have lined everything up and we've added zeros, it's going to be the biggest one. And so again, not a hard concept, it's just you've got to do the work. A lot of times when kids are going to miss these problems, they don't do the work. They don't want to show their work, they don't want to line up the decimals or add the zeros. And you're making a really simple problem hard because you're trying to fly through it. You have to do the work. All right, on this particular page, I thought I would show something that pops up every year, and I'm sure you ran into this last year as fourth graders, but this is where you're looking at two numbers visually right now. They look a lot different because you're seeing one that only has one digit, and then you're seeing a number that has three digits. But the reality is, if you understand this, if you understand about decimal numbers or just numbers in general, you know that sometimes they look different, but these are actually equal. And that is because if I go up to the top number, which is 9/10, 9/10, if I add zeros to make them look the same as the one underneath, then I'm really looking at 900 thousandths compared to 900 thousandths. These are the same numbers. If you were to go draw this out in a picture, this would be the exact same picture. And I know I really harp on this in my class. I say this multiple times a week, especially if we're doing something with place value. When you're dealing with numbers, you have to understand when you add zeros to numbers, especially in place values where you're dealing with decimal numbers, you can add a million zeros behind a number and it doesn't really affect it too much. It looks different, and how you would read it would be different, but the value's the same. So my saying is zeros hold a place, but they do not have a value. They don't, add a value to your number. And so these two numbers, even though they started out much different, they really are the same number. 9/10 is the same as 900 thousandths. And it would be the same here if I were to go and draw 90 hundredths. 90 hundredths would be the same thing, because again, if I add a zero to make them look the same, these are all equal to one another. So really, I know that's something y'all talked about as fourth graders. That's something that really has to kind of come back into play as fifth graders when you're dealing with these decimal numbers, because it pops up quite a bit. Make sure that's something that does not trick you, especially on a question, maybe on a test. They like to throw those at you. So be really careful. Same concept, line up the decimals, add zeros when needed. All right, this page is essentially the same thing as the previous page. Now you're just dealing with the whole number. So I have three numbers. I have 5 and 40 hundredths, 5 and 4/10ths, or 5 and 400 thousandths. These look like three completely different numbers, but if you do the work and you do what you're supposed to step by step, I think these all three are going to be the same. They're already lined up nice and neat, but if I make them look the same, I'm going to add in some zeros here, and I could tell all three numbers are exactly the same. They all could be said as 5 and 400 thousandths. So just remember that. Take the time, make sure that you're doing the steps to get all, line it up nice and neat, get all those zeros in wherever zeros are needed, and then do your comparing. All right, and on this last page, I just pulled a couple of things from our textbook. These are very simple problems. They're asking you to compare with a comparison symbol. So over the years, you have done this. Anything from Pac-Man to a gator's mouth, all kinds of different strategies for this. So this isn't new. Again, maybe the only thing that's new here is potentially maybe having to go to the thousands place. So I'm going to go through these. Question 1, this is a really simple one. You wouldn't have to do a lot of work here, because if you look carefully at the numbers, they're the same number of digits. And if I just wanted to make my life easy, I'm going to just line them up. And when I line up everything nice and neat, I notice I don't have to I don't have to add any zeros. But when I go to compare, I'm probably looking there in that tenths place. And there, the 3 is obviously bigger than the 2. And so when I compare these, I'm going to put a symbol in saying that 9 and 32 hundredths is greater than 9 and 23 hundredths. Okay, the next problem, I would start by lining up the decimals. Nice and neat here. But then the issue on this one would be I have to do a little bit more work, just a little bit, because they're not the same number of digits. I'm going to have to add a 0 in. But once I add that 0 in, this is one of those where, again, maybe going a little bit too fast. I could see some kids saying that 7 and 20 hundredths is greater than 7 2/10. But the reality is, once I've done the work, this is really simple to see. These are the same numbers. All right, moving on to the next one. Same strategy, lining up the decimals here. Once I line up the decimals, I can make them look the same. Notice the bottom number, 4 and 44 thousandths. That's going to the thousandths. So the top one, I'm going to make go to the thousandths now by adding a 0. That 0 holds a place, but it doesn't change the value. And then when I look at this, I definitely see 4 is the same in the ones place. So if I go to the tenths, but really, I kind of focus on just this. Like, I'll look at my decimals and I think, okay, well, hey, 440 is a whole lot bigger than 44. And so that's kind of where my eyes gravitate towards. And I go, okay, well, if I go back to the original numbers, 4 and 44 hundredths is going to be bigger or greater than 4 and 44 thousandths. And then the last one here, I'm going to line them up. I'm going to take a little bit different approach here, though. A lot of times I like doing this in my class. I always think this is good, especially heading into fifth grade. Be able to relate numbers to things out in the real world. So when I look at this, I could say it as a fifth grade student, and I could say 3 and 61 hundredths, or I would like to hear a lot of my students think of it as money. Well, that's $3.61 compared to $3.87. And that's a really easy comparison because $3.87 is going to be bigger than $3.61. So really, there's not a lot of work to do there. It still would be good to line up your decimals and add zeros if needed. You just wouldn't have to on this one.